Hey guys, welcome back. So today I received a shipment from a subscriber who lives a few states away. This generator was something that was given to him in non-running condition, and he offered to send it to me under one condition, and that was that I make a video on it. I don't think I said I had to make it run, but of course that is the hope. Anyway, this generator, it is branded Beacon, but it is made by Generac. It looks just like a Generac XL series generator, which is one of my favorites. They are very well made, and it's one of the few that actually has a pressurized lubrication system. Now, this is in pretty rough shape. It was left outside for quite a while, but even so, the engine, it's not stuck. It turns over and has very good compression. The throttle plate, though, it is stuck, so we'll have to take a look at that. This is electric start, and over here there is an hour meter, and surprisingly there's only 85 hours on this generator, so yeah, it's pretty young. I'd say it does have some life left in it with any luck. Let's get this off the pallet, we'll get it inside and take a closer look. What do you think the odds are of these tires holding any air? All right, that one's good. Let's see if this one takes any air. Not bad. First things first, I think we need to level this out before doing anything else. I'm going to start with the basics here. I know the engine has compression. Let's see if it has oil. That's on there tight. Really tight. Yeah. It's got oil. Definitely low though. So I'm going to top that off and then check for spark. Set the engine to run. Kill the lights. Okay, good. Looks like we have spark. So let's pull the spark plug, get a little bit of two-stroke fuel in the cylinder, and see if this thing will fire up for a second. No rust. Got the light plugged in and turned on, so let's pull that cord and see if we get any signs of life. Not too bad. The engine, it sounds good, and I think I just cleared a bunch of junk out of that exhaust, but I didn't see the light turn on, and I think it's because the engine wasn't spinning fast enough. So I'm going to put a little more fuel down on the cylinder. I'm also going to pull the cover off the airbox. So I'm going to start it again. We'll feed it a bit of starting fluid, see if we can't get the engine up to speed, and see if that power head is any good. Filter looks good. It's definitely a critter though at one point. Unfortunately, I saw nothing from that light, so I just moved the outlet to a different one on the control panel. So I'm going to try this again and hopefully get a better result. Unfortunately, that light is not coming on, so I think we do have some issues down on the stator. So let's get that end cover off and take a closer look. Before jumping in and just pulling that cover off the power head, I think I'm going to run a quick test through each of these outlets, make sure that the stator is actually connected to them. Now, on a clone generator, I usually see around 3.3 or 0.4 ohms. This generator should be lower. I'm guessing around 0.2 ohms. I've got 0.1 built in to these leads, so whatever reading I get, I can subtract that from it. And that reading is pretty high. So we might actually have a bad stator. Let's check over here. Yeah, that reading is very high. Let's check it through here just to make sure it's consistent. And it's not consistent. We get 0.5 ohms, which is really 0.4. 0.3, 0.4. So that actually seems good. Let's check over here on the other leg. Should be about the same. And it is. This one's actually a little lower, 0.3, 0.4, which is actually 0.2, 0.3. Let's just double check the first one. Might just be a little oxidation on the prongs. Come on. Yeah, 0.4. So it's really a 0.3. So a little inconsistent, actually. I saw 0.3 there for a second. So they're similar, very similar. Why the resistance is high here? I'm willing to bet it's these circuit breakers right here. They do tend to corrode, similar to how points would corrode. So yeah, maybe the stator isn't bad. This circuit breaker seems to be in much better shape. So potentially I could just restart it, try it through here. But even with the high resistance through all of this, we should have seen something. So yeah, let's get the end cover off that power head. Not good. Hoping these bolts don't break. They're fairly small and I'm sure rusted in place. Turned a little. Not sure if it was breaking. Doing something. Great. I somehow think they're all going to do the same thing. Yep. It's 2 for 2. Three for 3. 4 for 4. Okay, good. This is what I was hoping to see. This is the same setup that you would see in a Generac XL series generator. And this board here, this is the power control board, or the PCB. And it's what supplies power to the brushes. The input is the excitation winding. I think it's coming in on this side. And there is a 3-wire connector which goes up into the control panel. And there's a system control board up there which controls the output of this. So there's a few things I want to do here. I guess first off, I don't know what the problem is. Is it a bad winding? Is it a bad board? Usually these power heads are very reliable, so I'm more inclined to think either this board is bad or the one up in the control panel. So if I unplug this connector, it'll lose communication with the board in the control panel. And what that'll do is, if the system board is bad, then this will be allowed to power up when it's disconnected. It'll go to full power, about 170 volts on the 120 outlets, but that'll tell me if the system control board is bad. So I think that's where I'm going to start. We'll get this 3-wire connector removed, and maybe even before then, we'll test the excitation winding, make sure the resistance is good. Ideally, I would test the brushes as well, but I don't think I'm going to try to get those bolts out based on what happened over here. So yeah, let's just check the excitation winding, unplug that 3-wire connector, and try it again. All right. Get that out of the way. Just going to use the multimeter to test the ohms. And usually excitation windings on generators like this come in at about 1.5 ohms. We're at 1.7, so that seems good. Check it to ground. And there is a pretty strong connection to ground. So yeah, potentially the stator's bad, or maybe it's picking up the connection through one of these other wires that have not been disconnected. Not sure, but I would say let's just reconnect these wires. We'll leave the 3-wire connector unplugged. We'll start it once again, see if there's any change. All right, let's try this again. This time, the light is hooked up to the breakout cord, so I'm actually plugged in to the only outlet that tested well. So I'm going to get some fuel down that cylinder again. We'll try starting it and feed it a little bit of starting fluid to keep it going. Unfortunately, same result. There's no output from this generator, so there is something wrong here, and based on the test I did a second ago on that DPE winding, I'd say the stator is shorted to ground, and most likely it is bad. But before condemning it, let's fully isolate the stator. We'll do some more thorough tests and just make sure. Let's just start by getting this power control board uninstalled. So we'll get the excitation winding unplugged. Get these wires out of the way. They should slide out like that. And remove them from the brushes. Now, it looks like the white wire is on the outside, which doesn't seem right. I thought positive should be on the outside, which I would have thought was the black wire. So, you know what? Let's reverse those and try starting it again. But while we got the wires off, let's at least check the resistance of the rotor. Should be between 8 and 10 ohms. Might be a little higher through the brushes. A lot higher. It's a pretty high connection, but the slip rings might be dirty. We'll check it to ground. No connection to ground. So yeah, let's continue and reconnect this if possible with the white wire on the inside. All right, let's give that a try. Well, it's worth a try. I'll double check the wiring diagram later, but I'm fairly certain the black wire should be on this outer terminal. But still doesn't work. So let's just uninstall this completely. And we already checked from the brushes to ground. There was no connection. The resistance is very high. Ideally, I would check on the slip rings directly by removing the brushes, but based on what happened here, I'm going to leave those alone for now. Get that unplugged, and these wires, they are labeled on the wire 22 and over here 22. So when we unplug them, we should know where they go. This is wire 44 and 44. 11 and 11. These are the main windings, leg 1 and leg 2. These others are just auxiliary windings, so power for charging the battery. And there's also a DC output on the front of the generator. And then we have 2 wires here which connect over to the bridge rectifier that feed up to the control panel on the blue wires. So I think those are the last 2 connections, but I'm curious here. Before removing them, do we still have a connection to ground from the excitation winding? And we don't. So that's a good thing, I think. Stator may not be bad. So now that we're fully isolated, let's check the main windings here. We got wire 22, 44, and 11. I believe 22 is the common wire, or the neutral. So if I test from here to either of these other 2 wires, we should get that reading we saw up at the outlets, around 0.2, 0.3. And I get nothing, but that's because that is the stator side. This is going up to the outlet. So let's try this again. This is wire 22. .3 ohms. Seems good. Let's check it on the other leg. Same reading. We'll check it to ground. No connection to ground. And wire 22, it is commoned up between leg 1 and leg 2. So the fact that there's no connection to ground tells me that both the main windings are not shorted to ground, which is good. Excitation winding, we already just double checked. That connection to ground is gone. Let's check this auxiliary winding to ground. No issues there. So the ohms for the main winding and the excitation winding are good. Ohms for the rotor are questionable, but at least they're not 0. Let's just check from the main windings to the excitation. I was going to say there should be no connection, but in this case there's a direct connection. So that most likely is not an issue, depending upon how this generator is wired. And no connection there. So it seems like maybe the stator is good. I guess this is the only question mark, why it's connected to the main winding, but yeah, I don't know enough about this generator to say if that is a bad thing. On other generators, I would say it is a bad thing. But this one, not sure. Anyway, I think I've done all I can do down here. I need to research this a little bit more, but what I'm seeing is promising. It leads me to believe that either the board, the power control board, is bad, or potentially we lost residual magnetism. So one thing we can do is get the engine running, supply 12 volts DC to the brushes, and see if we get output on the stator. But before I can do that, I need to get the engine running more than a few seconds. It needs to run on the carburetor. So I think that's the next move. Let's get that carburetor off and see if it can be saved. I was just taking a closer look at this board. The black wire, there's some sort of defect right there. There's a bump in the wire. So I started wiggling the wire, and it honestly doesn't feel like there's anything connected there. So the wire has corroded, and yeah, it's no longer attached. And actually, if you look here, this is probably a transistor, and it looks like it let out the magic smoke. So yeah, I think, well, I know we need a new one of these. Whether this is the only problem preventing it powering up, I don't know, but it's definitely a problem. So I'm going to get a new one of these ordered up, but before I do that, let's look at the carb, see if I need to order one of those as well. Those are pretty loose. So I tend to think the power head is good, and someone was troubleshooting an engine issue based on how loose that was. There's 2 more here. And there is a switch on the side here, which you can disconnect if you want to get the airbox off all the way. In this case, we have the access we need. I think the tricky part is just getting the governor arm off because of how it goes through this blower housing. It's a little tricky sometimes. So theoretically, you can lift up and bend the governor rod a bit, and it should come out, maybe. There we go. Let's cheat. We'll take a quick peek. It's promising. You can tell a lot by that drain bolt. If it doesn't come out or it's all rusted, then you know you got a problem. It does smell though, very, very varnishy. And the throttle, it's not completely stuck. It does move, so that should free up pretty easily, I would think. It's not bad, actually. There's no rust. Some really, really bad fuel smells a bit like deck stain, but I think that kind of saved the carburetor because it's very oily. And yeah, I actually don't see any corrosion on the carburetor or the bowl. So this should clean up pretty well. All right, let's see if this will fully come apart. So, pin is stuck. We're off to a good start. Let's try the main jet. Main jet's coming out. Pilot jet is right here. This actually might be a cap, or it could be the jet. I guess we'll find out. Yeah, it's just a cap. I think down there, there is a teeny tiny jet. So let me find the right size screwdriver for that one. Is a tiny, tiny jet. Idle set screw, we can leave that alone. So really, it's just this pin. That's the issue. So I'm going to tap that a few times, see if I can get it to move. Yeah, it is moving. But it's not coming out, not without tapping it. You got to go easy on this. These arms, they tend to break real easy. This one actually is a lot beefier than most. Usually they're very thin slivers of aluminum holding that pin in place, so it is pretty easy to break. Where did it go? It's gone. It's gone. Thought I lost it, but it's right there. Most likely I'm going to have to sand this down a bit to get it to go back in. Should be easier than coming out, but thankfully I had this punch pin set. A subscriber named Taylor sent this to me, so without it, it would have been a lot harder. So thank you for that. Main jet, it is plugged solid. Pilot, I would say, is impossible to tell, but I'd say there's a good chance that is clogged as well. So let's unplug them. Maybe. There we go. All right, that's good. And for this little pilot jet, I'm just going to use a wire from a wire brush. It's really tiny, the diameter, and I would say has the best chance of fitting in this hole, if I could even see it. Well, if it was plugged, it's not anymore. So those are good. As far as the throttle plate goes, that should just free up, soaking in the degreaser, so I'm not too worried about that. On this side, we have a few passages. Let's just check them real quick. Make sure they're not plugged. That one may have been plugged. That one's good. And the emulsion tube, I don't think is removable on this one, so we'll just run a brush up it, make sure it's not blocked. And it's not. That's pretty much it. So the needle I'm going to leave out. I don't put those in the ultrasonic because the chemicals do damage that needle. And I think everything else is going to go in. A cheap man's lathe. Hey, it fits. Nice. Give it a little bit extra this time. Let's see how we're making out. Bull looks almost like new. Carburetor looks pretty good too. So I'd say it's almost done. I'll give it another 5 minutes or so, and I think we'll be ready to put this thing back together. Cleaned up pretty well. Almost like new. Anyway, everything's been washed with water and blown dry. So let's start by getting the pilot jet reinstalled. We'll get this cap in place. Make sure it works. Like this, needle should be closed. So when I blow through this line, you should hear nothing. If you hear anything at all, it's going to leak. Seems to work fine. All right, let's try it out. Forgot to mention too, the throttle plate completely freed up from the ultrasonic. The anti-lash spring completely rusted away. The other piece is right there. So yeah, we don't need it for testing, but that is going to cause it to surge potentially, even if the carburetor is perfect. So that will need to be replaced, but yeah, I'd say for now we'll just ignore it. I think we're out of threads. So, need to add a spacer. Destroying the gasket. Oh well. I think we're ready to go. I filled up the bowl just using this fuel line right here. We fed it some fuel and it stopped right there. So the needle and seat, they are working. So let's get this started, see if it sounds good and if the governor has control on that engine. All the wires, they're still disconnected, and I just double checked to make sure none of them are going to get sucked in by the rotor. So I think we're good to go. Very nice. That carburetor is running the engine very well. So the engine, I'm not concerned about. It's doing what it should. It does need a bunch of little things, but yeah, the main issue is that power head. And to that end, I actually messaged Gary about this board, better known as Bass Guitarist 1985. He has a YouTube channel and is on Smokestack. He is a bit of a generator guru, and I dare say knows more than me about generators. Anyway, he specializes in Generac XL generators, and he rebuilds these boards. So I sent him a picture of this board, joking that it should be an easy rebuild, and he said, yep, send it. And I thought he was joking, but he's not. He says he can rebuild this for about half the price of a new board. So yeah, I think I'll give him a shot. I have no doubt that he can do it, if anyone can. So with that in mind, though, I do want to test one more thing. I'm still not satisfied with the way that excitation winding is testing. It might be normal for this generator, I don't know. But the thing I can do is apply 12 volts DC to those brushes now that the engine can run and sustain itself. So if I do that, while the engine's running, I should get enough power output to light that light bulb. So let me get everything set up and we'll give that a try. So here's the setup. And I guess first off, which terminal is positive? And I thought it was the front, and I was correct. But what I misinterpreted is that the white wire on this power control board is the positive, and the black is the negative. So this was connected properly before I switched the wires around. And what I've done here is connect two alligator clips, one to each terminal, the red one being the positive and the black the negative. And right now I have it connected to the multimeter measuring ohms. And now that the generator has run, or the engine has run for a bit, you can see the slip rings cleaned up quite a bit. We're now down to about 15.6 ohms, which is a lot closer to where it should be. So that rotor should work just fine. Now, the plan is to get the engine running again. And I'm going to use a battery to supply power to the brushes, being sure to respect the polarity. So the red will go to the positive and the black wire to the negative. It's also running through this 7.5 amp fuse, which should be plenty. The rotor should not be pulling more than 2 amps at 12 volts. And once I attach it to the battery, that light should light up. We're not going to get the full power output. It's probably going to be closer to 100 volts, maybe a little bit lower, but that's okay. Really, all I want to see is that the stator does work and that light comes on. All right, let's give this a try. I did also reconnect the wires to the stator going up to the outlets. So that's wire 11, 22, and 44. So let's get it started, see what happens. Nice. We have power, and to be honest, I didn't really give this one much hope when it initially didn't produce power, given the appearance of this generator. But yeah, I think the stator is good. So I'm going to send out the power control board to be repaired. And when I get it back, we'll get it installed. We'll do another test and see if it can power up with the repaired board. Now, there are other components in the control panel that also control that board. So I wouldn't say we're completely out of the woods yet, but things are looking pretty good. So I just ordered a couple parts for this engine, including that anti-surge spring and a new oil filter. That'll be here in a few days. Every time I start this engine, stuff is blowing around. And I just took a closer look here at the corner of the head, and you can see there is stuff kind of jammed in there. So there was definitely a mouse or something living in this blower housing, and a lot of the stuff is blown up here in the cooling fins. So I want to get some of these tins off and clean that up. But of course, I'm a little nervous given what happened on the power head. So hopefully these bolts don't break, but I don't think we have a choice here. We need to clean that out. Looks like this is also held in by tiny little 8mm screws going around, but these don't look as crusty, so I would say we do have a chance. Anyway, I'm going to get the tank out of the way. I do want to use the impact on these. I have a lot better luck breaking bolts free instead of breaking them using the impact. So let's get that tank out. Nope. Not too bad. I was expecting to see worse, but there is some crammed in right there, kind of on the bottom of the head, and there's also some on the top. And that's definitely going to cause a cooling issue. So let's get that out of there. Not sure what purpose these used to serve, but they're not serving a purpose now, so I'm going to take them off. Actually, before I send that board out, there's one more test I can do. I'm going to start the engine like last time, apply power to the brushes like last time, and that light should turn on. But I've also connected a small 20 watt, 120 volt halogen light directly to the excitation winding. So if this winding is healthy, this light bulb should also light up. So let's give that a quick try. That was a very good test. It told me a lot and gave me some reassurance that the excitation winding is good, because when I connected power to the brushes, the excitation winding was able to power this 20 watt bulb without issue. So the excitation winding can handle a load. Of course, the main legs handle a load as well. So I have no reservation about getting that board repaired. Gary got this back to me pretty fast, and he made a video on it. He posted it to YouTube, so I'll leave a link to that up above and down in the description. Now, this one, he said, was the worst he has ever seen, and that is saying something, because he has repaired a lot of these boards. He actually sent me a picture of this board after it was depotted, and you could see the extent of the damage physically on the board. One of the traces had actually burned up the board, and a couple others were damaged. So he reflowed the solder on the traces that he could, and on the trace that was burned up, he ran a jumper to complete the circuit. And surprisingly, the diode, capacitor, and varistor all tested well, but all the other components had to be replaced. So he bench tested it. It tested well. So let's get this plugged in and get the engine started, see if it can power up on its own. All right, I got the board installed and pretty much ready to go here. I did reconnect that 3-wire connector on that board. So that connects the power control board to the system control board in here. And if everything's working properly, the system control board should control the power to the brushes and regulate the voltage to about 125 volts. So let's get this started and see what we get. We got power. We had power. Well, the good news is the repaired board works. The generator powered up on its own, but after starting it, it stalled immediately. And I kind of dismissed it as just a cold engine. I turned the choke off too fast. So I started it again. And I think I may have made a mistake there, because after I did that, the engine went under a very heavy load. And by the time I realized it, the damage was already done. So I had a camera rolling on the side, running in high speed. I'll just replay that footage for you now. And I just looked at it, and it's not good. So yeah, that repaired board, I think it just melted down. And I heard lots of crackling sounds after I shut the generator off. So something definitely got very hot in there, and it shouldn't have done that. So there is something wrong. I think this generator is going to be a parts machine, but I don't like taking things apart without understanding what's wrong with it. And I should be able to test that with the multimeter. So let me give this one a little more thought. I think I'll get that board uninstalled and take a look at the carnage. It's hard to tell, but I think right there, that might be a diode. That might have been what popped and went up in smoke. So yeah, I'm at a bit of a loss on this one because it was bench tested with 120 volts input and it output the correct DC on these wires here. So really the only difference was, well, it was plugged in to this generator, but I also had this 3-pin connector plugged in. And I haven't done any testing on the system board, but I did notice the control panel is loose. So I think I'm going to open that up and take a look inside. Potentially someone moved some wires around. I'm not sure. I've been looking this over for a couple minutes. I traced out the 3 wires coming up from the stator, and everything seems to be connected where it needs to be. I don't see any evidence of tampering. I guess the only thing that stands out as a little odd is this blue wire right here. It runs over to the system control board and is tapping into one of the 120 volt outlets. Not that this is odd in the fact that it does need to monitor the 120 volts, but it's tapped off the circuit breaker on this side. The part that's protected by the circuit breaker is on the other side. So this wire going to the system control board is unprotected. And really what I was looking for was evidence of a short circuit here. When this generator started, the engine went under full load. I think this is a 15 horse engine which can power 8,000 watts. So I think it was discharging somewhere 8,000 watts. And if it was up here on this thin wire, it would have been melted and charred. And I'm seeing nothing that's charred up here. So yeah, I don't think the issue's up here, but to be sure, I'm going to disconnect these 3 wires down on the stator. We'll do an ohms test between neutral and each of the legs and just make sure there is no connection. I've got all the wires disconnected going up to the control panel. So what I want to do is check between neutral and each of the legs. There should be no connection unless there's a short circuit. No connection to leg 1, no connection to leg 2, and no connection between leg 1 and leg 2. So there doesn't seem to be a short circuit. The other thing we can check is just from one of the live wires, leg 1 to ground. Nothing. And nothing. So the control panel I don't think is the issue, and if it was, these breakers should have popped, and they didn't. So I don't think the issue's up here, and I did retest down here using this meter, which is a low voltage test. Didn't find any changes from before. So I'm going to break out the high voltage tester and we'll do some insulation testing again on the stator and the rotor to see if we can't figure this one out. For this test, I'm just going to use this insulation meter set to test at 1,000 volts. The other meter I have tests at less than a volt, so this should be a very good test. And what I'm going to do is just connect one lead to ground, and I cleaned a spot off right there, so we do have a good connection. And I'm going to use wire 22, which is the neutral wire between leg 1 and leg 2. So by testing this, I'm actually testing both leg 1 and leg 2 to ground. And we're at 280 million ohms. So that is not an issue. Let's check the excitation winding to ground. No issues there. 290 million ohms and climbing. And we'll check it to this DC auxiliary winding to ground. No issues there. We're at 1 giga ohm and climbing. And let's just check from the brushes, from the rotor to ground. About 110 million ohms. That should be fine. So I don't see any faults to ground from any of the windings. The only other thing we can really do here is to test from the main windings to the auxiliary winding, but this wasn't even connected the last time I started it, so I really kind of doubt that's going to be an issue. Yeah, about 2 giga ohms. So yeah, I mean, I would still say, despite what just happened, the stator and rotor, they test good. There's no issue. So I'm going to repeat my earlier test. I'm going to set it up with a light on the excitation circuit. We'll get these wires plugged back in. We'll get the drop light connected and put 12 volts to the brushes and see if it runs normally or if it goes under load again. All right, I think I'm ready to go. It's pretty much the same setup as last time. The only difference is that I added a multimeter right there to measure the AC output from the stator. And I also connected the excitation winding again to a light, but also that multimeter so I can see what the output looks like there. So let's get it started and see how it goes. All right, let's give this a try. I'd say that was a very good test. I got about 100 volts out from the stator, and that's what it should be for this generator when applying about 12 volts to the brushes. And the excitation winding was about 130 volts AC, and both those lights lit up, and the engine did not go under load, but it did a few times sound like it was about to, but it actually just ran out of gas. It was starting to surge. So I want to do this test one more time just to make sure. This time, though, I have the external fuel tank hooked up. So that shouldn't be an issue. So let's try it again. Seems like it's good. So it's got to be one of those control boards, but it still doesn't make a whole lot of sense because though that board, it only controls the amount of power going to the brushes. So let's say it's malfunctioning, and instead of sending 36 volts to the brushes, it's sending 100 volts. The only thing that's going to do is stress the rotor. It's going to put too much power in, it's going to heat up, potentially cause it to fail, and the magnetism is going to be stronger than it should be. But that shouldn't cause the engine to go under load. What causes the engine to go under load is when you pull power out of the stator. The more power you pull out, the stator actually builds a magnetic field opposing the rotation of the rotor. So that's why you need more horsepower for larger generators. It's because of the current acting against the rotor. And when I connected that board, the engine went full throttle. And this is a 15 horse engine. And that should be able to pull 8,000 watts before reaching full throttle. So yeah, something still doesn't add up here, but as far as I can tell, the stator's good. It's the next day, and I pulled the system board out. I was going to send this and the power control board to Gary to bench test and try to figure out what's going on here. I also sent him a link to all the footage you just watched, and I think he's in agreement that it seems unlikely that an issue with the brushes would cause the engine to go under full load, but based on the testing, the stator and the rotor appear to be good, so the issue must be in one of these boards. So he did offer up two possibilities. The first one is that the repaired board is the issue. He didn't replace every component, and although they tested well with a bench test, when putting it into service, potentially something buckled. So yeah, that is a possibility, but then he said something else which caught my attention. He asked if I plugged the number 2 wire onto this tab right here from the excitation winding, and the answer is no. I actually paid no attention to it because it's AC going in, so it shouldn't matter, and it's DC coming out. And I definitely connected the DC side properly to the brushes, but that got me thinking, how did I connect it? So I took a look at the footage, and I did connect it backwards. So I would say on most generators that wouldn't be an issue, but as I saw earlier, the excitation winding is connected to the main winding, and the system board is connected to one of the legs. So yeah, hooking it up backwards could be very bad because the way this generator works is that there are two legs, leg 1 and leg 2. Each one is 120 volts, 60 hertz, which means it switches polarity 60 times a second. Now, these are not in sync. When this one is positive 120 volts, This one's negative 120 volts. And that's why if you measure with a multimeter between the two legs, you're going to get 240 volts. But if you measure between the hot wires on the same leg, you're going to get 0 volts, or pretty close to it. So if I connect this one way to the excitation winding, the net voltage difference would be close to 0 between one of the main outputs from the stator and the excitation winding. If I hook it up backwards, then the difference between the excitation winding and one of the legs from the main stator could be 240 volts. And that's what this board would see. And that could definitely lead to what we saw. So yeah, this board, it is damaged, but when I shut it down last time, it was still making power. So I'm going to hook this up the right way. I'm going to leave the system board out of the equation, so there'll be nothing on this 3-pin connector. And I'm also going to disconnect the control panel and just measure the voltage with the multimeter, because with the system board out of play, this is going to go at full power and it's going to produce about 170 volts on the 120 volt outlets, which would be good. That's what I want to see. And I also want to see that it can do it without that engine going under load. So I'm going to hook this up real quick. We'll try starting it again. Thought we had it for a second, but the engine, it went under load, so I had to shut it down. So even though it wasn't the result I was hoping for, it still gave me a lot of good, useful information. First off, the system board was disconnected, so we can cross that off the list as the possible cause, and the control panel was disconnected as well, so that is not the issue. It has to be that board down there in the power head. Most likely I damaged it when I connected it backwards. So I'm going to send that one back off so Gary can have a look. I'll send him this one as well. You know, at this point, I'm thinking maybe a new board would be the way to go, since that one was so severely damaged to begin with. But either way, this video is getting pretty long, and I wasn't expecting all the issues down there on the power head. I thought the real story here was going to be the engine and just getting this thing functionally 100%. And at this point, that board has to be sent out. It'll be another week. So I think I'm going to cut the video here. We'll do a part 2. We'll try this again with a repaired or a new board. And if it's the same result, we'll have a teardown video. If it works, then we'll finish this thing up and get it functionally 100%. So I hope this video helps someone. Thanks for watching.